So what is command redirection? Well, we've actually already seen it. When we did our echo with the redirector, when we did our pipe and grep, we actually redirected data. More specifically, we redirected data streams. So let's get a terminal open now on our left-hand side in Docket. And I'm actually going to open up a text editor on the right-hand side and make some notes that you can reference back and forth as we go along. Everything revolves around 3 streams of data. And these data streams have names. One of them is standard input, known as standard in, and another one is standard output, known as standard out, and then we have standard error, which can commonly just be called to standard error. Now they also have shorthand names of stdin, stdout, and stderr. Additionally, these data streams are actually represented by numbers. Standard in is 0, standard out is 1, and standard error is 2. Okay, and so that's all well and good, but what does that actually mean, right? Well, just consider standard input or standard in to sort of be these keys that I'm typing into the terminal right now. I'm typing away, and what's happening is the terminal is capturing my keystrokes and populating this line to ultimately become standard in. Now, if I hit enter right now, and I'm about to do that, so what you're about to see here after I hit the enter key is going to actually call an error. And that text that appears to us in the terminal is actually the standard error data stream. That's standard error presented to us right now. So now if I ran another command that's actually valid, like echo in quotes hello, that's standard in, and when I hit enter, that hello is actually standard out. So let's do this one more time. I'm going to echo again, and I'm going to write some text. This is all standard in that I'm providing right now, and when I hit enter, what's actually going to happen is I'm going to get output given back to me, and that output is standard out. So an easy way to remember is that standard out is just regular valid output, and standard error is also output, but it's error information. It's a separate data stream for a purpose. Now these data streams will make more sense when we look at redirectors, and that's what we're going to look at next. Redirectors manipulate these data streams in order to provide advanced functionality in the command line, like we've seen. So this greater than sign, this is the redirector just to redirect standard out. That's all what it actually does. And typically it's supposed to go somewhere, normally towards a file. And then we have the next redirector, which we've also used before, and this actually appends standard out. And again, normally commonly to a file like we've seen. So just like in the left terminal now, when I did echo the output of this is standard out, that output just got dropped to the terminal. But if I wanted to append that output to a file, I would use the double greater than sign operators there to take that output that went to the terminal and append that to a file like we've done previously, adding lines to a file on the command line. Okay, so now we just are going to be redirecting the other way. And that's what the less than symbol is actually an operator for. It's actually to read to standard in of a command. And that's going to make a lot more sense. We just need to demonstrate that on the command line for that really to stick. So let's move on and look at the next one of double less than sign. And this double operator here is actually a little different. This is kind of weird compared to the others. This is going to read multiple lines of text between 2 patterns of text. So in this case, everything between those 2 EOF markers will be the text, and even multiple lines of text that will get sent to be read to standard in. And that's very different, and it's actually much more advanced, and we're going to walk through it. But as a quick example, that might be good to store multiple lines of something somewhere else. And then finally, we have our old pipe. So this is how we've been able to pipe and grep. And the pipe, as I mentioned before, takes the standard out of whatever's on the left, and it just redirects that as standard in to the next set of commands after the pipe. And these are some tough concepts to grasp right away. So don't pressure yourself thinking you need to understand it right away. Let's just walk through it one at a time. And then the more we use it, the more we practice with it, the more it'll actually just start to make sense. So let's use the first redirector right now. And we're going to echo hello and redirect that output of hello into the hello.txt file. We can cat it here and we'll see that it's stored hello. So that hopefully explains more now why that redirector actually works. And similarly, the append or the double greater than sign operators, they work the same way. So instead of echoing and just dropping to the terminal, we would just redirect that terminal output and put that inside of a file. And that's how these text patterns are getting stored inside of files. We're just redirecting data streams here. So let's do something kind of cool now with the standard out. Let's just cat, no file name, just cat redirect standard out to a bunch of text.txt and watch what happens. We can just start entering a ton of text, line after line, some text here, another line of text right after that, and we can just keep on going. And what's happening now is all that standard out is just getting stored on the terminal. And when we're ready to terminate it, we can press Control C. Now go ahead and cat the file and watch what happens. All of our text is inside. So remember that the cat file we talked about initially was redirecting the contents of the file to standard out. So if cat doesn't have a file to redirect, it's just going to wait for us to provide something, and then it will just redirect it to a file. Now that's kind of cool. There's actually a lot of layers of complexity behind everything happening. Now let's take a look at the next set of operators, and these are the ones that more so read to standard in. And we'll demonstrate that with the WC command, which will just print out words, lines, and characters. If we did WC tacl on hello.txt, it would let us know that there are 2 lines of text inside. Now we can also do this with the redirector to read to standard in. And we'll do the same command, but then just read from hello.txt. And there we go, 2 lines of text. And this is actually really handy if we don't always just want to be stuck with reading from hello.txt. Maybe we wanted to read the line count for whatever we want to give WC tacl. This provides a lot more flexibility. And this works with any other command. So like the sort command, we can also just get hello.txt and put that into sort, and it'll sort it out line by line for us, just the same as if we ran sort on the file itself. And again, that major advantage is that we're not tied to hello.txt anymore. We could give any other file we'd like, and it would work. And now let's look at the next one with the double redirector going the other way. This one looks most complicated, but once you go through it, it'll make more sense. Let's say we wanted to read the number of lines in a given amount of input, and we don't know what the input is. Well, we could use this double redirector the other way, and we could tag it that EOF, which stands for end of file normally, is the final line of entry of the end of the file. So if we were to just give a bunch of random input here, let's say 4 lines of text, and we waited till we then saw the EOF tag, then once the EOF tag is interpreted, it would send those lines of text as the standard in to the WC tacl command, which in this case is 4 lines of text. That's pretty cool. And again, in this case, it's just an advantage of flexibility. If we wanted to receive an unknown amount of multi-line input into a set of commands, this is where you would use that. Okay, so let's look at standard error now. And this one behaves slightly differently because it's an entirely different data stream. So if we were to cat some fake file that doesn't exist, we would get an error, right? And what if we wanted to store that error in like an error log or something? Well, we could do cat some fake file and then redirect it and put it inside of error.log, right? Well, let's cat error.log and it's empty. So it didn't actually carry over. Now remember, and look at my notes here on the right-hand side, that redirector only redirects standard out. So what if we actually wanted to store all of our errors to an error.log? Well, we can do that using those number representations of the data streams. If we throw in a 2 for standard error in front of that redirector, notice how the error didn't appear in the terminal. So that's a good sign. That means it worked. So let's cat the error.log now, and we're going to see. Awesome. So we actually were able to redirect standard error into the file itself. So we've manipulated the data streams. That's pretty cool. And it works as well with the append. If we did 2 and then double greater than symbol, it would then append the errors to the error log. So now we can actually create an error log recording multiple lines of errors that our commands might create. Okay, so let's carry on here. And let's actually try to cat some fake file, and we're going to try to put the error into something called dev/null. And this is a special place inside of Linux, which is like a void. And we're going to go and also redirect the standard out to error2.log and demonstrate what happens. So some fake file doesn't exist. We tried to cat it, there's no output, and that should go to error2.log if there were. And then 2 over to dev/null means that the standard error that we should have seen on the terminal here went to nowhere. It just gets deleted into oblivion. Now let's cat error2.log and take a look. There's nothing inside. So that's interesting. Let's walk through this a little bit more and see what's going on here. If I run a command like echo hello and I redirect it into dev/null, nothing happens. It really is just a void you can send things to. Okay, so let's actually put everything together and start demonstrating some use cases for all of these redirectors. Let's say we wanted to get a running snapshot of all the processes at a given time. Well, we can list out the proc folder itself, and the output of that we can just instead redirect inside of a reader like less, right? Now we can read all of the contents inside of proc. And that's how we would use it with the pipe. We would pipe it over to less and then we can read it, but we can also save it. So we could do the same command. We can ls the proc directory and then redirect that into, I don't know, maybe like a proc snapshot type of file. Now we can put that inside of a reader and we have a moment in time of all the running processes on the given system. That's kind of cool. Now let's take it a little bit further. Remember that etc password file? Well, let's take another look at that. If we look at the left column, this first column here, that's actually all of the usernames in the system, right? Well, what if there is a way to manipulate this output and get a list of just the users? So let's cat etc password again and pipe it. But this time we're going to pipe it to a new command called cut. And the cut command works by giving it tacd for a delimiter, and we're going to say colon. The delimiter is basically like a separator. So what do we want to separate this output by? So if we separate by colon, as we see above, we can now slice up the output. And in order to view our slices, we need to use tacf, and that would allow us to select the field, so which slice we want. And 1 would represent the user column. All right, so now that's kind of cool. So what if we wanted to get 2 of the columns? Well, we put a comma and then put 1 and 2. And now we can start doing that again and again, right? 1, 2, and 3, 1, 2, 3, and 4. And we can start doing more advanced things with this output. So let's go back and take just the first column, so just that slice, and let's pipe it again. Let's actually pipe it and sort it now. So we can run the sort command and it will sort the list of users on the system. This is kind of neat, right? We can keep on doing this and get a more refined, distilled version of the users on the system. So now we can output this to users.txt and we can read this at any given time. Now this is the list of users on the system. And of course sorted, I might add. And now let's take it even one step further. What if we wanted to get a count of the users on the system? Well, let's do one more pipe, and this time run the word count, so wc tacl, and then redirect that to number of users.txt. And now we actually have 52 users on the system. This is when things start to get more fun in the command line. And take your time with this stuff. This is definitely one of the harder labs in this module, and one of the generally harder concepts to grasp right away. But once you start getting over this hurdle, as you can see at the end, you can really start having some fun in the command line.